Welcome to the 1.2.3 notes, area as a product and a sum. Neither of these notes are going to come out of the notes packet itself. They're going to come directly from the book. So if we take a look at these, and this may or may not be a review for you. It kind of depends on the experience that you've had previously when it comes to the different tiles that we use. So I pasted them off to the side over here on the right-hand side. So I'm kind of looking right here where I just highlighted in yellow. And what we have here are different sets of manipulatives. So if you check the link in the agenda for the resources, there are tiles that I have linked for you. You're welcome to cut them out and use those to kind of build this as we go along, which I highly recommend. So we have a couple of different tiles here, and we think about them in terms of their dimensions, and we think about them in terms of their area as well. So if we take a look at the very top one, this little one up here that I just circled in orange, we would call that the unit tile because it has an area of 1 unit. So the area here we would say is 1 or a single unit. Then we've got a whole bunch of these other ones too. Now we want to make sure that we have some sort of a generic length of either X or Y. If you actually have the manipulatives in front of you, the X tile and the Y tile look a lot alike. It's just that the Y tile is a little bit longer. That doesn't mean that Y is always larger than X. You guys know that. It is just so that we don't get them confused with this whole idea of being able to kind of pick up these tiles and move them around and get them to do what we need them to do when we're trying to build these problems. So if we take a look at this one here, we would say that this is has an area of X because 1 times X is X. So we're going to call that the X tile. And then if we take a look over at the longer one, kind of the same shape, so just a long skinny rectangle, then we're going to refer to this as the Y tile, doing the 1 times Y. And then moving over, we have this other one, which honestly, we don't use a whole heck of a lot most of the time when we're building them. And that we would refer to as our XY tile. You could call it the YX tile. We typically do, and by we, I mean math people, whether you're in a math class or you're teaching or you're a student or anything. We typically put things in alphabetic order, although it's not necessarily required. And then we also have, oh, looks like I cut off the bottom of this. I apologize. This one is an actual square. So that dimension there is X. These are pretty popular. This is going to be an X squared tile that we use quite a bit. And then our very last one here, in the right corner, this dimension is a Y. And it's just a tiny bit larger than the other one, and this is going to be your Y squared tile. So you should be able to take a look at them in your tool set with these types of questions and see if you can go ahead and build the things that we're going to be building. Ideally, what you want to do is you kind of want to follow like a guideline. And you don't have to do it this way, although in the beginning, it's highly recommended. You want to make sure that as you're going through and building these, that your tile that has like the greatest area, if you want to think about it that way, so you're like your X squared tile or your Y squared tile, the tile that has the largest area in comparison to everything else you typically want in the bottom left-hand corner. So I am going to take that X squared tile and I'm going to draw it down in the bottom left-hand corner. Now, it doesn't have to be perfect. We just want to make sure that it is a square. So there is my X squared tile. Now, the X squared tile has a dimension of X and X on each side. Now, we're going to try to make a rectangle out of this. When we're building, we want to build up from the X squared tile, and we want to build to the right from the X squared tile. We don't want to build to the left or below it. We're going to try to build out from it, so up and right. So with that said, I take a look at the next tile that I have with a large amount of area, and that would be the 8X. So I have 8 of these little X tiles here that I have circled off to the right-hand side that have just a little red X in the middle of them. So you want to have 8 of those. Now you have to figure out where you're going to put those. You can build them up on top of the X squared. So we could put some of them up here. But you want to make sure that the dimensions are appropriate. So this dimension of X has to be the same dimension here and here and here. We're trying to create, again, a rectangular piece out of multiple little puzzle pieces. You don't want to put 2 puzzle pieces next to each other that don't belong together. So match your dimensions as you go. That's very important. So if we put this in here, this could be an X tile, knowing that this dimension here is X, the one that I highlighted in blue, and the other dimension down the side of it, which I'm going to color orange for you guys right here, we need that dimension to be 1 if you're using an X tile. So there is 1 of your X tiles, but you have to use 8 of them. So let's say I put another one right next to it. Okay, then this would be a 1 also. But I need 8 of those X's. So the challenge is making sure that you're building them in the correct direction. So what you can do is you can put all of them up or all of them to the right and slowly start sliding them around. That's one way to do it. Another way to do it is to kind of start putting some up and some to the right. So I think that's what I'm going to do here. So I'm going to put an X tile here, again, only building out in the direction I'm allowed to. And I just kind of take stock of what I've used so far. So I have 1X, 2X, 3X, 4X. But if you look back at the question, I have to have 8X tiles. So I'm going to keep playing around with this and see what I can come up with. So I need to put some more in. And where they're going to go, I don't know. We might have to do a little bit of guess and check. So I'm going to put another 1 on top here. That's an X. And then I can actually start sliding the singles in if you want, because we got to get 12 singles in here also. So here, there's 1. Again, I'm trying to create a rectangle, so I have to fill in the gaps. So there's 1 and 1. And then 1 and 1. 1 and 1. Okay, so I've got 5 X's used so far and 2, 4, 6 singles. I still have a ways to go. So let's see what else. So I've got, let's build some more over here and see if this is going to work for us. There's another X. There's another singles. So filling in as I go. All right, so I've got 6 X's and 3, 6, 9. Okay, so let's build one more off to the side here. All right, so I've got 7 X's so far. So I'm looking at all of the X tiles when I keep saying or totaling up what I have. I still need to have 8, so it looks like I'm short 1. Now you can put it off to the right or you can put it on the top. It kind of depends on you. But again, this is like a guess and check situation that I'm going through. And then if you guys have gone through and used tiles in the past, we're not going to spend too much more time on this. I just want to make sure I don't lose everybody in the process of this. So if we go through, we've got 1, 2, 3 tiles, 4, 5, 6, 7, 8. Okay, good. Now, we've got all 8 of our X's out there, but we have to make sure now that the 12 units are taken care of. We can't use more than 12. You've got to use 12 exactly if this is going to work. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got a problem. So I think I have too many singles right now, which I'm not allowed to have, which means I'm going to have to do some readjustments here. So I think what I'm going to do is I'm going to take off this last row here. This last thing of green, and I'm going to move it up. So instead of having the X tile on the bottom, I'm going to build it on top. Maybe that'll take care of it for me. But again, I don't really know. It's going to take a little bit of guess and check again. So I'll move that away and I'm going to put the X up here instead. So let's build it here. And then maybe that'll do it. Again, I don't want to go over my x's, can't use more x's, can't use more singles. So if I take a look at this, I now have let's see, I think I've got 8. Okay, good. Now I need to take a look at the singles. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got more problems. Okay, so I still have too many singles that I'm using. All right, I'm going to do the same thing that I did just a second ago. I'm going to take this section down the right-hand side, the whole thing, and I'm going to slide it up on top. Hopefully that's going to work. So let's erase this now. So this is what I mean by it's just a little bit of guess and check as you go. Now, the more you practice this, the easier it is. But this is kind of our first time of building it. And then in the future, so with the next couple of problems, oh, we've got our dimensions here also. With our next couple of problems, if I were you, I would go through and try to build them first myself and then come back and see what I end up having. All right, let's see how we're doing on the singles now. So I still have 8 x's, but now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I still have a problem. Okay, so I think I'm going to try this one more time. I'll go through and see if I can move this one up, but it may not work. So I think we're just going to have to play around with this a little bit more. So I went ahead and I shifted up another column and then I double checked and I think we got it. So I have my dimensions on my x squared tile. I've got 2 singles on the edges. Just remember, we've got to match up the dimensions here. Got 2, 3, 4, 5, 6 singles. And then double check again and make sure that you aren't using any more tiles than you're allowed to. We have 1 x squared. We have an 8 x's, so we've got 8 of the long skinny guys, and then 12 of the little tiny units. The last thing that we want to do is now rewrite this. So all of the original question that was given to us, so I'm going to go ahead and box in red. So that question that was given to us, that was written as a sum because you've got multiple things being added together or subtracted. We think of that as a sum also. Because we can do negative signs. So they're all written as a sum. Now our job is to write it as a product, and that's all the stuff around the outside of it. So if we take a look around the outside here, we've got this dimension across the bottom. Now, none of the sum was written with negative signs, so it's all positives right now. So across the bottom, we know this is going to be able to be rewritten as a positive x plus, and I'm going to go ahead and combine like terms with the 1 and the 1, so I get an x plus 2. Additionally, I can do the stuff down the side. So I want to take those right there. I'm going to do the exact same thing here. So I know that I'm going to have a single x plus, and then add up all of my 1s going down the side, and that's going to give me 6. Then if I want to rewrite the question, so go back up to the red box, we want to rewrite it as a product. Put an equal sign next to it, take the dimension from across the bottom, which we got as x plus 2, and you're going to times it by, so product does mean multiplication, the dimension down the side. Now, if you have worked with tiles in the past, spectacular, and you want to do a generic rectangle, I don't have a problem with that at all. But I did want to make sure that I spent enough time going over this, since this is going to lead into a gigantic concept for us this year. Huge. So I'm going to go ahead and move on to the next one of the 4x squared plus 4x. So go ahead and take out your tiles and see if you can build it. Now, I know this one's a little bit trickier because you've got 4x squared tiles. So if it were me, just a recommendation, I would keep all of my x squared tiles kind of right next to each other and see if I can just build, okay, there's my rectangle so far, but then I still have to deal with the x's. So there's my 4x squareds. So those are my x squared tiles. But now you still need to build x's off of them. Remember that you have to match the dimensions. So this orange dimension is x, which means you can put the x tile as long as the x length is next to it. So go ahead and give it a shot and see if you can build this. Remember, you want to build straight up or to the right. Don't go left or down. Okay, so this was my first attempt, and it didn't work. It absolutely did not work. And I know it didn't work because there's a hole right there. So you have to make sure that you don't have any gaps. So I would scrap this process and try it again. So maybe put the x squareds a different way. Maybe stack them all up on top of each other instead of trying to make a little box in the right-hand corner. So I think I'm going to start from scratch again. Okay, I think I got it. Now, I chose to build it out long ways, so kind of horizontally, but you could have also built this vertically if you wanted to. I think we'll get the exact same answer. So I'm gonna go ahead and put my dimensions in now. So all of my green tiles were x squared tiles. So I know that the dimensions on those are x and x. So all of those are x's. And then the dimension on the orange ones are my 4x's. So they're x tiles. Well, the long dimension is already taken. So if I've got this x, that means that red dimension length is x. So the short length is going to be the 1. There's no negative signs in the original question, so I'm going to go ahead and rewrite this out. So across the bottom, I had 4x. So x plus x plus x plus x. And then up the side, I ended up with x plus 1. Now, you don't necessarily need the parentheses around the 4x, but you could have also written this as, maybe you built it tall, so it would be x plus 1 times 4x. It doesn't matter, you get the exact same answer. Remember that multiplication is commutative, whether you've heard that vocabulary word or not. It simply means it doesn't matter what order you put it in. So if you guys did 4 times 7, it's the same thing as 7 times 4. Okay, so why don't you see if you can build the 2x squared plus 7x plus 1. Remember, it's got to be a rectangle. Put the x squareds in the bottom left-hand corner and then build up or to the right, but you can't have any gaps. Good luck. Okay, I don't know about you guys, but I tried multiple ways and I couldn't get this to work. And that's okay, because sometimes it can't be turned from a sum into a product. If that's the case, then we would say that this is prime, which means it cannot be written as a product. So that's good to know. All right, so not everything works, but we're going to try and make sure, just kind of juggle stuff around and really look and see and go, oh, well, nope, okay, there's nothing I can do. Okay, if you take a look at this next one that we have here, we have both an x squared and a y squared, and it's tricky. You don't know if you're supposed to start with the x squared or with the y squared. Going back to what I said earlier, you might want to start with the one that looks like has the greater area, which is the y squared itself. But you do have to make sure that you still put stuff next to each other that belongs together. So you can't mismatch your dimensions. So why don't you give this one a shot? You want to have, make sure you don't have any more tiles than you're allowed to have. You want to have a single x squared tile, a single y squared tile, and then 2 of the xy tiles. See if you can make it into a rectangle. And again, kind of a big area on the bottom left if you can, and like build out from it if possible. Okay, here's what I got when I built it, making sure that the dimensions matched when I put them in. So if I go to my y squared tile, so my y squared tile, I'm going to use a bright yellow on this. My white squared tile has a dimension of y on that side, which means when I take the xy tile, I have to make sure that the longer side is sitting against that. Additionally, this yellow is also y length. So I want to make sure that I have a y length there. You can also write the dimensions on the outside. So we know that wherever this y is located across the bottom, you move it up It's got to match that length on the top also. Same thing on the left-hand side. Okay, so then that means that the other dimension, so the dimension on the green tile, the xy, well, the y is already taken, so that's x. The y is already taken down here also. That's x. Okay, and then just double check and make sure. If this red is an x length and you carry it all the way across, then all of those reds need to be x lengths, which they are, so that's good. Same thing down here. We've got that red length of x, move it up, red length of x. Okay, good. So it looks like we have an x and an x, and that does give me my x squared tile up in the top right-hand corner. So now we're going to go ahead and rewrite this as a product. So my equal sign. So across the bottom is y plus x, and up the side is also y plus x. It's a great opportunity for us to remember what exponents do. And remember, if you have repeated multiplication, so like I have 2 of the exact same thing, I can shrink it down and use an exponent of 2, showing that that's the exact same thing. I'm just gonna write it twice. Okay, moving on to 45. On this one, everything's already filled in for you and you already have the rectangle put together. So it's actually kind of nice. A little bit less work than the other ones. So this is more practice in just being able to find the dimensions. So remember what we just talked about on the previous screen. So taking a look at this question, see if you can figure out what all of the dimensions are. Then we'll write it as a sum and a product. Okay, go ahead and double check yours against mine. I wrote my dimensions off to the side, and I use those things that are outside, so across the bottom and down the side, to write my product. So it's always the stuff on the outside that gives me the product. Okay, so across the bottom, it looks like I have 2 x's and 3 singles. So I've got a 2x plus 3. Then up the side, it looks like I have a 3x, and then I have 2 singles. Okay, so now there's actually a couple of different ways that you can determine what the area as a sum is. So here's your product. One way to do it is you can actually just go back to the tiles and count your tiles. So make sure you combine like terms though. So one way to do it is go over here and we can just count all the x squareds. So I'm going to go ahead and color code them green. So there's 1, 2, 3, 4, 5, 6x squared tiles. So I would write down 6x squared. Plus, you can do the same thing with your x's and the same things with your singles. But another way to do it, and I know that you guys have done this in previous years, is you can actually take the product that we came out with. So that thing I just boxed in red, and you can multiply it all out. So you may have learned it as the distributive property. Hopefully that sounds familiar. If you multiply that out, you're going to get the exact same answer as if we just total up all of the x's and the x squareds and the constants. So go ahead and finish this up. Okay, so now for me, I could have multiplied it out. I would have gotten the exact same answer, but I'm a big fan of not having to necessarily do more work than I have to. And there was already a picture here, and I could just as easily go through and just count them up. So if you take a look at the picture, that's what I did. I took all the x's, I color-coded them orange, and I tagged them up as soon as I was get the total, and I wrote it down. And then I did the exact same with the singles. Okay, so now on this next one, 1-46, what I want to do is kind of do a generic model. So what you'll see here in the picture is that we have a generic area model. So in the bottom left-hand corner, I do have an x squared tile, but I have 6 of them all together. But instead of drawing out all 6 of them, I'm just going to draw one big rectangle to represent all of them that are sitting there. And then I'm going to do the exact same idea with my x tiles. Notice that they were built up or to the right, or both, but we didn't build them to the left or down. Not at all. So we're still kind of following along with that idea of what we've done previously. And then in the top right-hand corner, just like always, we're going to put our singles up there. So again, if you've done this before, Thanks for bearing with me on the first couple of slides. But again, this is for the people who haven't necessarily worked with these before. But we're going to use generic rectangles more than anything else. So you just have to figure out kind of where things go. So on this question, we're going to take a look at the area model, and we're going to compare it to the previous problem. So if you take a look back at the previous slide, which I'm going to go ahead and do. So notice I had 6x squared, 13x plus 6. So 6x squared, there it is, 13x, there we go. If you add those two together, there's the 13, and then your plus 6. So I would say the only difference between this really, I mean, it looks exactly the same, except it has a lot less drawing in it. So I would say, kind of in your own words, go ahead and write down the fact that this is just a generic model of the tiles themselves. It gets across the exact same point. You just don't have to do the drawing of every single tile. Now, some people actually benefit from that. So if you do, don't stop doing it until you're super comfortable with it. So again, it's just kind of a generic model. So we're going to use that in just a minute. Okay, moving on to area model puzzles. At this point, we're going to use what we know about dimensions. And we know that with the tiles that we have used previously, way back on the first slide, we referred to tiles basically two different ways. One, we could refer to them in terms of their dimensions. So if we had an X on one length and 1 on the other, so that was one way we could talk about it, or we would talk about it with regards to its area. And I always wrote that inside the square itself or inside the rectangle. So if I had a tile that was an X tile, so here's my example. I've got my X tile here. There were a couple of ways I could have referred to this. I could have said, okay, well, the long side of it had a dimension of X and the short side had a dimension of 1. Okay, so that would be my side lengths. But then I would also refer to it as having an area. Well, one of the things that's important to note, and this goes way back, is the idea of just being able to find the area of a rectangle. You guys know that the area of a rectangle itself is just base times height. So if I take a look at this, my area is base times height. So the base is X, the height is 1. If I multiply those two together, I get X. Let's get rid of that extra dot there. Then if I take a look, I know that the area, looking at my picture, can actually be found inside, which I denoted as X originally. So look, we've got the area X we can actually find just by multiplying the length and the width. So we're going to use this idea of dimensions and areas and how they relate together. So if I take a look at just this first box here, this 3x squared, I'm already given one of the dimensions. I already know what it is. I was told that this length is X. All right. Well, if the area of that is 3x squared, we need to ask ourselves, well, what's the other dimension supposed to be? Like, how do I get 3x squared? So I need to figure out what that green length is. So if I've got X, that's already taken, X times what gives me 3x squared? And that's actually going to be 3x. Which means I now know the green length. And I'm going to slide that over. So that's also a 3x length, but then so is this one. So I'm just going to slide that guy over for the time being so I can get it closer to this 6x tile. All right, so now I don't know the dimension of that one. So I know the 3x, but I don't know what the blue length is. All right, well, if the area inside it is 6x, so 3x times what gives me 6x? Well, that's going to have to be a 2. So I know the dimensions now of this. So what I'm going to have to do is fill in the dimensions, which I did. Oh, and then I need to write an equation that puts the area as a sum and area as a product together. So let's do the sum first. The sum is the stuff in the inside. So the first tile was a 3x squared. The second tile was a 6x. Okay, there is the sum. Now we're going to set that equal to the product. Now I'm going to go back over here and I'm going to get rid of this extra little 3x I put on the side because I don't want it to confuse me. I want to do base across the bottom times height going up the side. And then we may as well put parentheses around that 3x, although there's no addition or subtraction sign, so it's not really necessary. So there's my product. So that covers our first problem. Now, if we take a look at the second one, there's a couple more problems after this, so I'm going to work these two with you, and then we'll move on to the next screen. And I'm going to recommend that you guys pause, because I'm going to, and then see if you can work it out and then check and see how you did. So on this one, so let's take a look. I know this dimension is x because it was already given to me. All right, so then I need to figure out what goes across the bottom here to get an x squared tile. Well, x times x, actually. So I think I'm going to get rid of the fact that I made it red. I'm just going to make it blue because it's the exact same length. So that has to be x as well, which means this length is x as well, moving it up. So now I have this one length that I'm coloring orange, and I've got this blue length of x. So I have 1 times x. Well, I know 1 times x is just 1x or x. I'm going to go ahead and write the 1 for now. Then I'm going to continue off to, I think I'm just going to finish the bottom on the right-hand side. So I have my x, which was blue. So let's go ahead and move that blue length over. Okay, so now I have x, and I'm looking right there, the x I just circled. So x times something has to give me x. Well, x times 1 gives me x. So I'm going to put a 1 here. Oh, that was already color-coded orange. So let's go ahead and color-code this orange so it matches. So that length is 1, which means this length is 1. But then going to the one on the left-hand side, I have that orange length that I can move over as well. So now it looks like I have a 1 times a 1, which I know is a 1. So I'm going to write it as a product and as a sum. So across the bottom is x plus 1. Up the side is x plus 1, and I'm going to go ahead and rewrite that as x plus 1 squared. And then inside, so combine like terms as you go. I've got an x squared plus 2x's plus 1, and then I'm just going to bring that down. X squared plus 2x plus 1. Okay, moving on to our final slide. I would pause. See if you can figure out the whole thing, the next thing that you look. So I'll wait a couple of seconds before I put it all in, but then check and see what you did, and then I think we'll be done. Okay, here we go. So the part C got a little confusing, not so much with part D, but you'll see over here, I'm going to go ahead and highlight it with little yellow boxes, is that this 3y across the bottom, oh, that yellow is not dark enough. So the yellow across the bottom, excuse me, the 3y across the bottom, I dragged all the way up to the top just so I could get it closer to the 3xy. I thought it made it a little bit easier to try to figure out what the dimension was. And then I was able to come up with the x dimension on the left-hand side. And then I did the same thing over here. I took the 3 on the bottom right-hand corner on part D, and I dragged it up to the top just to get it closer to the -9. You don't have to do that. I just did that to try to help myself out. Maybe not so much on part D, but part C did get a tiny bit confusing. Remember to keep track of your questions so we can go over them in class.